Finish him. Kill the guy now. You have the gun. Hit him. What's wrong with you?
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have last semester.
We eat by pounds on you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, you go to what you first born. Stupid boy.
Hello, good day everyone, and welcome back to 201MATHEMATICAL. Last week we discussed the differentiation of function under differentiation, and we see the various examples on how to differentiate
function of more than a variable with respect to a variable. That is the partial differentiation of the function in application of chain rule. This afternoon, we are moving further and we want to see how we can determine the stationary point of a function of two variables. The stationary point of a function of two variables. Don't forget, if we say a function of two variables, I mean two independent variables. But before we go to that, let me review what we knew under the ordinary differentiation. That is a function of one variable. Don't forget, if you have a function, let me say y is equal to f of x. If you have a function, this is a function of one variable, one independent variable. You will say, you will determine the stationary point. The stationary point of this function will be determined when you have dy dx to be equal 0. What does that mean? You will differentiate this function once. When you differentiate this function once, then you equate it to 0. You solve it, either quadratic, simultaneous, exponential, polynomial, any type of equation you have there, you solve it. You get the value of x. Then that is where you determine your stationary point. I'm talking of this brother. And if you want to determine the minimum or the maximum of this function will have minimum. It will be minimum if the square y, the s square, is greater than 0. Then I will say is minimum. That is where I will determine the minimum point. I will determine the minimum point here with respect to x. Then at that point, I will find the value of the minimum value from this y. I'm revising what we knew already. And this one will be maximum. I determine the stationary point. I will go the same way, but something will be different. Something will be different now. What will be different? Don't forget that this function has two variables. So I will determine the stationary point of this function if the z, the x is equal to 0 and the z, the y is equal to 0. What does that mean? This function that was given to you, you differentiate the function with respect to x. You equate it to 0. The same function, you differentiate it with respect to y partially. You equate it to 0. In that case, you get a simultaneous equation. Two equations at once. Equation will comprise of x and y variables. Then you solve the simultaneous equation to get the stationary point at x comma y. What I mean by at x comma y, the point of the stationary point will be x and y. That is, you will get the value of x, you will get the value of y. You can write it in coordinate form like this. Then that is how to get the stationary point. Let us discuss an example here before we move to maximum and minimum of this type. Let me discuss an example there. And this is the question. We have a problem for ourselves here. The question says this. Example 1. Determine the stationary point of the function. Establish the stationary point of the function z of x comma y is 2x squared y squared plus 4xy squared minus 4y raised to power 3 plus 16y plus 5. Yes. We want to determine the stationary point of that product. Very simple. Solution. My z of xy is this. The first thing I will differentiate this function with respect to x. That is the z of x comma y, if you like. The x. Differentiate this function with respect to x. Here, I will consider only x. Differentiating with respect to x only. Y will be kept as constant. And this one will be 4xy squared. Come here, differentiate x, which is 1, and plus 4y squared, because y will be held constant. Here there is no x, it will be 0. Here there is no x, it will be 0. Here is a constant. It will be 0. And I will equate this one to 0 now. I will now say, therefore, I will have my 4x squared, my 4x y squared plus 4y squared will be equal to 0. Which can be written as xy squared plus y squared to be equal to 0. I will label this equation 1. What have I done here is that I use 4 to divide through this equation, and I have this. Now again, let me differentiate this function with respect to y. The z of x comma y, the y. With respect to y now, x squared will be constant. It will be 4 x squared y plus this one will be 8 xy. This one will be 8. Then x will be constant. Y will be removed by 1. Minus this one will be 12 y squared. Multiply this one plus 16. Plus 16. Y this brother will be 0. This one will be 16. Now I will now have 4 x squared y plus 8xy minus 12y squared plus 16 to be equal to 0. I will equate it to 0. Look at the equation very well. 4 can divide every times. This one will be x squared y plus 8xy. No. by 2 by 8 will be 2 minus 3y squared plus 4 is equal to 0. I will label this one equation 2. Now, I will now solve equation 1 and 2 simultaneously. I will solve equation 1 and 2 simultaneously. So it depends on you. I can take my y squared to be equal to minus xy squared from this one, whatever you like, or if you like, let me factorize y from 1. From 1, I can have y into x, even y squared into x minus plus 1 is equal to 0. Y squared into x plus 1 is equal to 0. Yes, and I will have this one, y to be equal to 0. My y will be equal to 0. Sorry, sir. If my y is equal to 0 in that brother, then that equation will vanish. That equation will vanish. That's what I'm looking about. Because my y squared can never be equal to 0. No, I need the value of y. Then if I equate it to 0, that equation will vanish. In that case, let me do something from that equation. Let me do something there. I will come here. Or let me say from here. From 1, I can divide through by y squared. Yes. Y squared is here, y squared is here. I will now have x plus 1 is equal to 0. If I divide this one by y squared, I have x plus y is equal to 0. Then my x will be equal to minus 1. My x will be equal to minus 1. That is the value of my x. I will not put that x in equation 2. Put x in equation 2. My equation 2 will not be, don't forget this is minus 1. If I put minus 1 squared, it will be 1. Then I will have y. If I put minus, okay, let me just put it so that some people will not crucify me. Minus 1 squared plus 2 minus 1 y minus 3y squared plus 4 is equal to 0. Yes. Coming here, this one will be 1. This one will be minus 1. And I have y minus 2y minus 3y squared plus 4 is equal to 0. From that side, I will get my minus y minus 2y minus 3y squared is equal to 0, which can be written as, where is that brother 4? Plus 4 is equal to 0, which can be written as 3y squared plus y minus 4 is equal to 0. What I've just done is that I multiplied through by negative. Then we will change this brother to this. Solve this one with quadratic equation. Let me just help us to do that one. If I multiply this time, I will get minus 12y squared. Yes, that's the first step. The next step is that I will look for two factors. If I multiply, I will get minus 12. If I add, I will get plus 1. Then, but there will be variables of values of y will be attached to them. Then, look at that one. If I get 4y and minus 3y, 3 times minus plus 4 times minus 3 will give me minus 12. Plus 4 minus 3 will give me 1. I will not put these values inside this brother. I will have 3y squared minus 3y plus 4y minus 4 is equal to 0. From here, I will factorize. I will get 3y into y minus 1 plus 4 into y minus 1 is equal to 0. Then I will get 3y minus plus 4 and y minus 1 is equal to 0. Then I have 3y plus 4 is equal to 0 or y minus 1 is equal to 0. I don't suppose to do this one for you one by one. It's GSS2 topic. Then from this brother, I want my y to be equal to minus 4 over 3 or y is equal to 1. Can you see? Now, for two values have been derived for brother y now. For only one value of x. Only one value of x. Y has two values. Now, this is what I will write. The stationary point are minus 1, comma 1. That is, when my x is minus 1, my y can be equal to 1. And when my x is minus 1, my y can be minus 4 over 3. And that is the solution to that problem. So that is the stationary point. And from that, I will fly to minimum and maximum points. Minimum and maximum points. Minimum and maximum value. Minimum and maximum values of a function of two variables. Yes. Don't forget, when we have function of one variable here, we define that the square y, the s square will be less than 0, then is at a maximum. Then if the square y, the s square is greater than 0, that is greater than 0 is at minimum. But if this thing is equal to 0, I don't know. That is, I don't know what you call that one. Maybe it's neither maximum or minimum. But for the two variables, if for respect to what I've defined, if my the square z, the s square, can you see now? And the square y, z, the y square are both let me say this, are both negative. Let me write it in that word. If both of them are negative, what does that mean? This value is less than 0. This value is less than 0. Less than 0. If both of them are less than 0, and at the same time, and the square z, the s square, multiplied by the square z, the y square, minus the square z, the x, the y. Yes. If this expression is greater than 0, if it's greater than 0, then the function will have its maximum point at x comma y. So that one, it will have its maximum point Yes. We have the maximum point. And what I've made, look at this place, everybody. Let us consider this brother. This time. Don't forget, if some people write the square z, the y, the x, it's still the same thing. Don't forget, we have discussed this several times that this and this are always equal. They are always equal. Similarly, if the square z, the x square, and the square z, the y square are both positive, that is, they are greater than 0. They are greater than 0. Yes, they are greater, bigger than 0. And at the same time, and the value of this brother, the square z, the x square, multiplied by the square z, the y square, minus the square z, the x, the y, is greater than 0. Can you see? If it's greater than 0, you can see that the conditions here are the same. Then I will say the function as its minimum at x comma y. So if that happens, I'll say it has its minimum at x comma y. This one will be square. This one will be square. If that one happens, then let us see a problem. Let us see a problem related to that. Sorry, we are going to square this second derivative here and the second derivative here. If this one gives us positive, or this one gives us negative, and this one happens, then it's have maximum. This one gives positive, and this happens, which is the same condition, then we have minimum. Let us discuss a problem. Example. The question says determine the stationary point and the nature of the point of the function z is equal to y square plus xy plus s square plus 4y minus 4x plus 5. Yes. We want to determine the stationary point and nature of the point. What is the meaning of nature of the point? We want to determine that at the point of the stationary, is it positive, is it maximum, or it is minimum? Then we'll find the minimum value and the maximum value at that point. So let us look at the solution to that problem. So the first thing we are going to do is to differentiate these functions. I will differentiate these functions with respect to x and y. I'm going to find the z, the x. The z, the x will give us, this one will be 0, y, derivative of x here is 1, plus 2x here, minus 4. Minus 4, this one will be 0, this one will be 0. Then, the square z, the x square, second derivative. If you differentiate this one, you will get 2. This one will be 0, this one will be 0. The derivative of this one is 2. And this one is greater than 0. It means it's positive. Now, let us go for the second one. The z, the y. Differentiate this one with respect to y. Here I will get 2y. Come here I will get plus y. Because, no, plus x. Plus x. Y will be 1. Here will be 0. Here I will get plus 4 with respect to y. Here will be 0. Here will be 0 because there is no y there. Then, second derivative, the square z, the y square. Differentiate this one again, I will get 2. This one will be 0, this one will be 0. The derivative of this one will be 2. And also, this one is greater than 0. Both of them are positive. So, at this point, I can get the stationary point. Don't forget, if I want to get my stationary point, I have to equate this one to 0. This one implies y plus 2x minus 4 is equal to 0, which will give me y plus 2x is equal to 4. Or let me just make y the subject of the formula then. I will get my y to be equal to 4 minus 2x. Let me call this one equation 1. And also I will come here. This one will imply 2y plus x plus 4 is equal to 0. Let me call this one equation 2. So if I put 1 into 2, the value of my y, wherever I see y, I will put this brother. Now get 2 into 4 minus 2x plus x plus 4 is equal to 0. I have only variables of x. Now, here I will open the bracket, I will get 8 minus 4x plus x plus 4 is equal to 0. Yes, we move further, and on this one, if I had this, if I had this, 8 plus 4 minus 4x plus x, I will now get minus 3x plus 12 is equal to 0. I will now have x is equal to 4. My x will be equal to 12, will equal to 4. Then put x is equal to 4 into 1. I will have y is equal to 4 minus 2 into 4. Y is equal to 4 minus 8. Y is equal to minus 4. Can you see? It means the stationary point now is 4 comma minus 4. The stationary point is at 4 point minus 4. That is the stationary point. I've continued the work I wanted to do. Now, this is my second derivative. It's positive. This is my second derivative with respect to y. It's positive. Now, let me look at this condition now. What is the value of the square x? No, but I have to find the square x, the square z, the x, the y. What does that mean? It means the x of the z, the y. And that is the same thing as the x of what is the z, the y. The z, the y. Can you see? The z, the y is 2y plus x plus 4. 2y plus x plus 4. I will not differentiate this function now with respect to x. If I differentiate this one with respect to x, it will give me 1. Because this one will be 0, this one will be 0, the derivative of x will be 1. So if that is equal to 1, now let me come to the square z, the x square, multiplied by the square z, the y square, minus the square z, the x, the y, everything square. What is the value? This one is the same thing as what is the square z, the x square? Is 2. I now have 2. What is the square y, z, the y square? 2. Multiply by 2 minus this one is brother 1, and I will square it. That one will give me 4 minus 1, which is equal to 3. And look at this 3, oh, is greater than 0. Can you see that? Both second derivative of this function with respect to x and with respect to y are positive. Both are positive. And the value of this expression also is positive, which means the second condition has been satisfied. If both of them are positive. So the second condition I wrote under the maximum and minimum product has been satisfied. It means the function here is at minimum value. Is at minimum value. And what is the minimum value itself? We just discovered that it acts minimum value. But what is the minimum value? So I want to determine the minimum value before I write the final, the conclusion, the final statement. The minimum value, okay, or let me say this. Let me say this. Let us assume you have not determined what you want to do. Put x is equal to 4 and y is equal to minus 4 into z. Into z. Or let me call this one, let me even call this z equation star. Into star. Don't forget. Sorry everybody, I've gone back to call this question given to us star. Star. Oh, remember star. Now this one is star. If I put that one, I will get our z to be equal to 16 minus 4 squared plus my x is 4, my y is minus 4, minus 16, my x is 4 plus 16, my y is minus 4. If I multiply it by this, I will get 16. Here, my x is 4, I will get minus 16 and plus 5. It's just substitution. It's in JS1. So I don't know. Maybe you think I should substitute again. This brother and this brother will go. This brother and this brother can go. Then what is minus 16 plus 5? Z is equal to minus 11. Can you see? Minimum value. If you look at the value, it's minimal, very small, because it skews to negative side of the graph. If I want to draw the graph, this function will go to the negative part more than the positive part of the graph. Can you see? It's minimum. So I will not write the final statement. Final statement. This shows that 4 comma minus 4 is a minimum with minimum value z is equal to minus 11. That one was just written for you there. So since both the square z, the s square, and the square z, the y square are both positive, and the square z, the s square, bracket, the square z, the y square, minus the square z, the x, the y square is greater than 0. So it's at minimum point. And that is the condition. Now, I don't know. How can we rush the last example here and make... Okay, let me just do it in a summary form. The reason I want to do this one is that it is possible that a function acts no minimum or maximum point. It is possible that a function acts at a stationary point, that it acts no minimum or maximum. Then if it happens like that, we say it is shadow. I cannot determine either it is minimal or is bigger, because it means the company does not make profit, no loss. Just stay in one point. Okay, okay, let me just do that one. Estimate the stationary point of the function z is equal to s cube minus 3s square, minus 3x plus 3y minus 6xy plus 3x square y plus 36y cube minus 54y square. I know, if some people see this question in the exam, they will run away. That is too long. Don't worry. Just come. There's something I'm supposed to add to this. I've not had it for today. Then, next time, I will start from where I stop. Because of our time. But what are we going to do here? Let us just determine the stationary point. Then next time, we determine the nature of the stationary point of this function. I will just remind you, oh, I have taught the stationary point, now let me determine the nature of the stationary point. Now, coming to this side, the first thing I will do is to differentiate this function, the z, the x. Don't forget, I want to do just the stationary point. Now, with respect to x, I will get 3s squared minus 3, this one will be 0, minus 6y plus 6xy, this one will be 0, this one will be 0, with respect to x. And I will equate this brother to 0. I'm going to get 3s squared minus 6xy plus 6xy minus 6y minus 3 is equal to 0. Let me call this one equation 1. The z, the y. The z, the y, I will get, this one will be 0, this one will be 0. I will get plus 3. I will come here, minus 6x. I will come here, plus 3s squared. 3s squared. I will come here, I will give me plus 36. And here will give me minus, no. Is it 36? No. 36 times 3. 108. 108y squared. Then minus, if I multiply 54 by 2, to give me 108y. 108y. Then from there, I don't need to write plus 3 here. I can put this one to be equal to, what is it? 3x squared minus 6x plus 108y squared minus 108y plus 3 is equal to 0. Equation 2. If I call that one equation 2, I'll solve those two simultaneously. Some people will think, how will I solve this one simultaneously now? Very simple. So I'll solve this one simultaneously. What I will do is that I will first of all reduce this one from 1. 3 can divide everything. 3 can divide each term. From 1, I can have x squared plus 2xy minus 2y minus 1 to be equal to 0. Then, look at here. Y is common to these two terms. I can write this one as x squared plus 2y into x minus 1. If I use this to multiply this, I will get this. If I use to multiply this, I will get this. Isn't it? And it will be equal to 1. I've taken 1 to that side now. Then I can take this x squared to this brother. I will now get 2y into x minus 1 is equal to 1 minus x squared. Then from here, I can get my 2y. My aim is to make y the subject of the formula. I get 1 minus x squared over x minus 1. Then my 2y can be equal to, look at this brother. This x, 1 minus x squared can be written as 1 minus x, 1 plus x. Difference of 2 squares over x minus 1. I want to restructure this brother to fit this denominator, to fit this. I'm now get 2y is equal to, look at this one, will give me minus x minus 1. Look at this. Oh. If I multiply this by this, I will get minus x. Multiply this, I will get plus 1. You get this one. So it means x minus 1 is equal to minus x, minus 1 minus x. Yes. So into 1 plus x over x minus 1. This one will take away this brother now. I will now get y is equal to minus 1 plus x all upon 2. All upon 2. I will save this brother, I will call it equation 3. Then, if I call that one equation 3, from 2 now, I will put, or let me say, put 3 into 2. Put 3 into 2. If I put 3 into 2, I'll get 3 will multiply this one. Our time is running fast. Okay. Okay, let me just do something. 3 will multiply all this one square. Then this one will give me 3 into minus 1 minus x over 2 square. Yes. Over 2 square minus 6 into minus 1 minus x over 2 plus, okay. Or before I go to that, my equation 2 can be reduced. My equation 2 can be reduced. I can write my 2 to be x to the power 2 minus 2x plus, if I use 3 to divide this one, I will get 36 y squared minus 36y plus 1 is equal to 0. Now let me put my x. Then if I put my x, I will get, this one will be minus 1 minus x over 2, so that will be clear, square. These 2 will divide these 2, and this minus will change this one to plus 1 plus x. This one plus 36y squared minus 36y plus 1 is equal to 0. If I have that one, if I square this, it means I want to multiply this one twice. The meaning is this. Minus 1 over 2 minus x over 2. Minus 1 over 2 minus x over 2. So if I multiply this one, will multiply this. You get 1 over 4. This one will multiply this. I'll get plus x over 4. This one will multiply this. I'll get plus x over 4. This one will multiply this. I'll get plus x squared over 4. Then that one will give me 1 over 4 plus x over 2, 2x over 4. X plus x over 4. That is 2x over 4 plus x squared over 4 plus 1 plus x plus 3, 36y squared plus I didn't substitute x here. I didn't substitute x for this brother. That is double wahala for daddy body. 36 into this thing. In fact, we have lost from the beginning. We are substituting x for x. So it means, sorry, our time, because our studio manager is telling us that we have to go out. So we'll stop from there. Sorry, because of our time. We are substituting x for x. And I can see that we are running into trouble. It's like we are going to Sambisa Forest now. What will happen is this. Just keep this one from where we stopped here because of our time. Keep this one here. When we come next time, don't worry, I will just brush this one. I will tell you we have done this. I will not just remind you of this one in 1 minute. Then I will continue from here. We see that some functions cannot have stationary points, and so on and so forth. And thank you. God bless you.
Finish him. Kill the guy now. You have to come. Hit him.
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting for in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have you last semester.
We by pounds on you. Very stupid though. Change that section to ACTV right now. And oh God, the baby to have been first born. Stupid boy.